at part 1 of this unit. Now, first thing I'm going to say about this unit is I already touched on a little bit of this in the last unit, and I did that on purpose to help again, but it quickly gets a little more complicated. And that's when I introduce the algebra to you guys, and that's where you'll see in a second. Okay, so first of all, let's take a look at what specifically every grade 9 student in the province of Manitoba is supposed to learn in just this section. Okay? So you need to understand powers with an integral base and a whole number exponent by representing repeated multiplication using powers. Show patterns to show that a power with an exponent of 0 is equal to 1. Let me just speak to that point for 1 second. We will not be doing this today, so that's not something you're going to need to worry about today. And then solve problems involving powers. Okay? So the reason why I mention this is you had already seen this in the last unit. Can I have you boys not all clump together if you guys want to hang out? You can just go right outside the room and hang out there. Okay? Because that would be easier. So if you guys could all go back to wherever it is you think you're sitting, please go there. Thanks. Okay. So first thing, okay? In the last unit, I already introduced those 3 words to you. I told you they wouldn't be on the test, and they weren't. However, I did say that they would reappear in this unit. So already, you've at least heard these 3 words. In this unit, absolutely it will be part of your test because now it's part of the unit itself. I mean, the unit's called Powers and Exponents. As well, it relates to the term exponential form, another math term that you're going to see in today's presentation that really also is the same idea. Okay? So I'm going to repeat a little bit of what I've shown you already. I'm going to go fairly quickly, but just to remind you of what we're talking about here. Exponents and powers are a shorthand way of writing repeated multiplication. Okay? So rather than write something out like this, 3 times 3 times 3 times 3 equals 81, which is the standard way to write it, okay? Now you can shorthand that using the idea of the base and the exponents. So instead of writing this, instead you write the 3 with a little 4 raised up there, okay? And let's dissect what each of these pieces mean. That is the exponent, that is the base, and the whole thing is called the power. Okay? So this is also expressed in different ways. If you're going to read it or speak it out loud, you could say, for example, this could be said as 3 to the second, or 3 to the power of 2, okay? Or 3 squared. As well, you could say this is 2 to the power of 3, or 2 to the third, or 2 cubed, okay? So as you hear these things, and again, these things express themselves in various places, not just in math class, you kind of have to understand what this is talking about. This is the language of mathematics as it goes. There are some advantages to writing things this way. One, it's lazy and cheaper and easier to write. It's a shortcut, okay? But as well, as we start moving beyond just numbers into more algebra, this also comes into play, okay? So it gets more complicated as we do that. Okay, this is also said to be written in exponential form. That's what it means. It just means that instead of writing it with a bunch of 5s, you're writing it with 5 to the power of 3. Again, different ways you can say it, including now this way, 2, okay, to the exponent of 5 is what's being said there. Just like here you could say this is 5 to the exponent of 3. Okay? All right, as I said to you before, and by the way, I couldn't have been more, this couldn't be a better I told you so moment than on Friday when I said you gotta get a calculator when we ran out for the test of calculators, okay? You need a calculator. It's part of the course. It's part of the requirements. You're gonna need it all year. It shouldn't always be one you borrow because it's easier if you just have your own and get used to it. Because already some students were wondering, how do I do powers on my calculator? Luckily, it wasn't on the test, so you didn't have to worry about it. But it now will be. So you need to know how to calculate 2 to the power of 8. And you don't want to do this by hand. you want to use your calculator. So you're going to be looking for keys like that one, y to the x, where you would punch it in the order to calculate what that value is. Okay? Okay, and these were some we did this a couple weeks ago, so I'm not going to have you do this again. All right. Now, also, this was also something that threw some of you off on the test, is the idea of negatives and when they come in. And I've seen it year after year after year that they always throw questions like this on the final exam to just make sure you're paying attention. I talked to one student today who lost 2 marks, I know for sure, on the test. Just, they had the right answer, but just the wrong sign, okay? It's just such a simple thing. It's just so bad when you just miss that. So be careful about that. Remember, in this case, the negative sign applies to the answer. So it doesn't matter what 3 to the 4th is. The final answer will be negative. However, in this case, it does matter because 3 to the 4th, the whole thing is being raised to the power of 4, okay? So be careful. And you can do this by just kind of punching it in your calculator properly if you get used to your calculator. Okay, here's where it gets a little harder now. This is not a review from last time. Now that we're going to start looking at algebra, you guys need to know about variables. And I think you do, but let's be clear about what we're talking about here, okay? Math is a language. It's a way to communicate values and expressions and numbers and to communicate amounts. Algebra is one of the languages that math uses as well to represent things that we don't know, okay? And the way that's done is through the concept of what's called a variable, okay? Now the reason it's called a variable is what it is can vary. The word vary is right in the word variable, which vary means to change, to constantly change. It's different each time. So this idea is that we have this thing that can represent different numbers at different times. We don't know what the number is, okay? So without variables, if we didn't use variables, all of our math would just involve numbers, okay? Whether in decimal form or fractional form or whole numbers, all of our math would just be numbers. But that would limit the ability to do certain things in math, okay? Sure, we can use multiplication, addition, subtraction, and things like that to combine the numbers, but we'd still be limited in how we could solve any problems with math. And that's the whole point, right? Is I need to figure out how much wood I have to buy to build my fence. I have to figure out the timing on this carburetor. I need to figure out how much chemical to put in this reaction that I'm doing in chemistry. All kinds of things will involve math as a base to figure those things out. And very often you don't know how much of something, and therefore you kind of need something to extend your math to do this, okay? So, for example, I could just use a symbol, okay? I could say triangle plus square equals square plus square. And what those shapes represent could be anything. But they're only anything if it actually calculates properly. So for example, if I replace triangle with a 1 and square with a 2, I would have a true statement. I would say 1 plus 2, that's 4, equals 2 plus 2, that's 4. 4 equals 4, yes, that's correct. However, if I replace the triangle with a 2 and the square with a 3, and I punch that in, it's no longer true. Now it's 2 plus 2, 4, plus 3, 7, equals 3 plus 3, which is 6. 7 doesn't equal 6. So I can use symbols like this, but those symbols represent numbers. And it's not just some random number, it's specific numbers that are making this thing actually happen. Okay? Now, this is all pretty and stuff, but the reality is we don't want to draw triangles and squares. Well, we'll talk about that in a minute. Oh, here's another way you can think of variables. You can think of variables as a box, a mailbox even. However, unlike your mailbox at home, where you can stick lots of things inside, this mailbox can only hold one thing at a time. Okay? So obviously we're going to put numbers in this mailbox. I'm going to put a 5 in there. Okay? If I'm going to change what's in the mailbox, what was in there before had to go away. So it represents one thing, one value. Okay? So here, I made a little animation for you guys. 75. Nope. I want it now to equal 10. Okay? So to use a variable to actually have it work in your math, we need to give it some sort of symbol. Okay? So we can't use numbers. We already are using numbers. And we could use squares and triangles. That would work, but first of all, I don't want to count on your drawing skills to draw squares and triangles, because some of you would do really beautiful ones, but others maybe not. As well, there's only so many shapes that you can actually draw. So the traditional language of mathematics is to use letters to represent values that we don't know yet. So some value plus some other value minus some other value equals 20. Okay? So those represent unknown values that either we're going to look for, we're going to try and do calculations to get, or I will later give you the value. So let's try a few. Okay? But at this point as well, I want to remind you guys, and I already talked about this once before, that since you'll be doing multiplication with your numbers, you gotta maybe move away from the symbols that you use for multiplication in earlier grades. There are 4 ways that you can multiply things together in algebra. Okay? This is the standard way that maybe you've been taught up to this point, is to use that X symbol to represent things being multiplied together. Okay? Guys, last warning. If you don't want to be here, if you want to check your phone, go right out there. Check your phone all day long. I have no problem with it. Being in here, checking your phone and talking, rude. I tried to say it out to everybody. Nope, got to keep doing it. So the last warning. Happens again, you're staying after school. Okay? And I'll use that phone to call mom and dad, or mom or dad, or whoever I get a hold of, and explain to them why you're pissing me off here today. Okay, I feel better. Whew. I've calmed down. I think I need a little sip of coffee. All right. So we have the symbol, the cross, but I think we're going to be moving away from that from now on. So this is still used a little bit. The dots means the same thing, things being multiplied. Last unit we also looked at how you can also use brackets, right? So this also means A times B. But as well, now that we're using variables, also know that by directly joining the variables or directly joining a number in a variable also means to multiply them together. Okay, so all those mean the same thing. They all mean to multiply. Okay? Now, another term you should be familiar with, okay, is the term coefficient. A coefficient is the expression, or sorry, pardon me, is the number that's being multiplied by a variable. So in just this 2y, 2 is the coefficient. We'll talk more about that in a little bit, okay? As well, you should also be familiar, and again, we're going to talk about this more later, that this is called an algebraic expression. This is called an algebraic term. This is 3 terms in that expression, okay? We'll also talk about other things, like the number 10 is what's called a constant. Obviously, x and y are variables. The coefficient of y is 2. So you can start to dissect a piece of algebra into different words, okay? And we'll kind of talk about that later. Okay, so now that we have variables, we'll build that into the whole exponents thing. Okay, let's take a look. Rather than deal with 27, it's easier to write 3 to the power of 3. But we can do the same thing with variables. We can say y to the power of 6, which really means y multiplied by itself 6 times. We can also get even more complicated. We can do this, 3y4, or 3 times y to the power of 4. Now what we have here is we have a lot of things being multiplied together. If we just take y4, we're talking about y being multiplied by itself 4 times. But we're also multiplying it by 3. So this means the same thing. Same with down there. X squared y means x times y. So a lot of things being multiplied together. But clearly this is much more shorthand than writing all that out. And notice how confusing that is again, using the x to represent multiplication. It's easy to, especially if you're writing that in pencil on an assignment, really hard to figure out what we're talking about there. Okay? So now here again is that idea of the coefficient. A coefficient is a number that multiplies a variable. It's different than a power. Okay? So we have a coefficient of 3 a variable called y, and a power, or an exponent, called 4. This, again, makes it tricky, right? It can quickly get more complicated. Notice this one, where the brackets are here and the exponents on the outside, means that. 3 times y times 3 times y times etc. And again, if that just means 3 times y, it's really just this. It's just everything being multiplied together. Okay? So it's really that. 81 times y to the 4th. All these 3 lines all mean the same thing. Okay? But it gets complicated. You're going to have to get a grip on it. So you're going to have to practice this. Okay? Same with this one. xy squared really means x times y, which is really just x times y. Or x squared y squared. Okay? And what we're going to see as you start using exponents more is there's patterns to these. Patterns that will work out into what I call laws, exponent laws. Okay, so it quickly gets a little more complicated as things move along. All right, so let's try one. Let's try an actual question now. Okay, so I'm going to tell you, this is the expression, 5x to the power of 4 plus 6xy. Now before you look even at what's written there, let's think about what this means. It means 5 times x, and x is being multiplied by itself 4 times. So it's really 5 times x times x times x times x. Okay. What this means is 6 times x times y. But now what I've done is I've given you what x is, and I've given you what y is. So now you know what the numbers are. So now you can use those numbers to calculate the answer. So first suggestion I always make is when you substitute, and hopefully you've heard that word before, this number into here, use brackets so you don't screw up the signs and stuff. So let's see how that goes. Okay? What I'm going to do is I'm just going to write this now by putting the 2 in there. So all I did was I take those x's and I replaced them with 2's. So where it was 5x, it's now 5 bracket 2. And right here it was 6x, it's now 6 bracket 2. And I do the same with the y. I know the y from up here is negative 3, so instead of putting a y, I put a negative 3. Now, if I look at just this side, I can calculate that. Okay? I can calculate what 2 to the power of 4 is. I can calculate what 6 times 2 times minus 3 is. I can put that in my calculator, or I can do it by hand. And then once I have a number here and I have a number here, I can add the 2 together. But you got to be kind of careful. It's a lot of math going on there. But there I can get it. 2 to the power of 4 is 16. 6 times 2 times negative 3 is negative 36. 5 times 16 is 80. 80 minus 36 is 44. Okay? So you got to kind of slowly break that all down. All right. Now let's try another one. Again, watch how important the parentheses is in here, or the brackets. Because the x is a negative 3, watch how this goes here. Okay? Okay? I replace the variable with the number in parentheses. So where an x was, now there's brackets and the negative 3 goes inside. Now if you think of it, what's negative 3 times negative 3? What is it? Positive 9. But remember, there's still a negative on the outside. So don't forget that in the end, that negative sign will apply to the final answer. Tricky, right? Tricky, tricky. Okay? Now let's try this one. Let's see if you guys can calculate this one. Just do it in your head. X is negative 2. What's x squared? What's x squared? 4 is correct. Positive 4. Okay, and again, by using the brackets, you can see that we're squaring both the negative 2 times negative 2. Okay. Let's wrap today with a couple quick final examples. Now, some of these we did last time, so I'm going to kind of escape some of these because we did all these. If you look back in the last set, they're there. Okay, so if you want, I can do these. Anyone want me to do these? No, you guys don't want to hear me. All right, so let's try a couple new ones. State the coefficient of this expression. Anyone have a guess? What do you think the guess is? 5. Anyone have a different number? What's x? No, x is not the coefficient. X is the variable. Okay, I'm just going to put the lights up because I'm having trouble seeing some of your hands here. Okay, what's the coefficient of that? I have one answer of 5. Anyone have a different answer? -5. Okay? -5 is actually the correct answer. Okay? -5 is the coefficient. Okay. Now, this one we could calculate that one, so I'm going to skip over that one. Okay, what about this one? Could you do that one? Evaluate x to the power of 3 when x is -4. Okay? Well, remember, and I'm just going to dive over to the smartboard for a second to write that one out. Oops. Okay, where are we? Okay, so we have x to the 3rd when x is -4. Remember, my technique, I think, is take your variable and replace it by -4, but always put brackets. Always. Can't recommend that strongly enough. A lot of people can do it without the brackets, but I wouldn't recommend it. Now, put the power back. So what that means is really this, -4 times -4 times -4. Now that means 4 times 4 times 4. I don't even care what 4 times 4 times 4 is. The question is, what's the sign of the answer? Well, it's a negative times a negative. That's a positive. But then a positive times a negative, your answer is going to be negative. Okay? And then what the answer actually is, 4 times 4 times 4. Doesn't really matter. You guys can do that one on a calculator. It's the sign that would have tricked you if you weren't paying attention. Okay? Oh, by the way, notice how that could have thrown you off if you didn't use the brackets. If you didn't put brackets in and you went like this, oh, it's -4 to the power of 3, you would have remembered what I said before, which is, oh, well, that negative sign applies to the answer. And in this case, you would have got it right, because the answer would still be negative. But if this was a 2 and not a 3, and you would have put a negative on the answer, you would have been wrong, because that one would have been positive. But with the brackets, you would have got it right. Okay? So the brackets is kind of a safety net to make sure you do it right. Okay, and then the same with this one. T squared plus s squared when t is -3 and s is 2. Let's try that one. Okay? So it's t squared plus s squared, I think. Now I'm losing track of my memory again. Yeah, -3 and 2. So this is -3, and this one is 2. Okay? But remember, you're rewriting this. But instead of putting a t, you put the -3 in brackets, squared. Plus, instead of s, you put 2 in brackets. Okay? So now again, it's -3 times -3, +9, plus +4. Okay? Will give you the right answer there. Okay? Watch out for the sign. I was heartbroken marking the test when students had the right answer but just left it the wrong sign. Okay? All right, so as we wrap today, okay, the key concepts here of this particular lesson is a power, a base, an exponent, a variable, a coefficient, a constant, and yes, you should use a calculator. So really it's just those words. It's the words, power, base, exponent, variable, coefficient, constant. These last two, coefficient and constant, I'm not too worried if you don't got those down yet. But for sure you should at least have the first 4, a concept of them. Okay? So that you can address what it says in the math curriculum. Okay. And notice again, this one here, we're not going to look at this today. We're not going to look at something equal to 1. We're going to get to that later. Okay, so here's what the assignment's going to look like that you guys are going to get. You're going to get it right now. Okay? It's a bunch of questions, so let me just go over the questions just so that you're clear as to what you're going to be answering with these questions.